calculation of nth derivative at x equal to 0. Question is y equal to sine inverse whole square. Then prove that a equal to 1 minus x square times y2 minus xy1 minus 2 equal to 0. And the second part, 1 minus x square, yn plus 2 minus 2n plus 1, xyn plus 1 minus n square yn equal to 0. Deduce that limit x tends to 0, yn plus 2 divided by yn equal to n square, and find yn at x equal to 0. Let's see the solution. So we are given y equals sine inverse x whole square. We can differentiate it. So y1 will be twice of sine inverse x times derivative of sine inverse x 1 upon root of 1 minus x square. Now let's write it as equation number 1. Now we make cross multiplication. So y1 times root of 1 minus x square equal to 2 sine inverse x. Now we square it, we will get y1 square 1 minus x square equal to 4 sine inverse x whole square. But we have sine inverse x whole square equal to y, so this will become 4y. So we have got y1 square 1 minus x square equal to 4y. We find second derivative. So this will become 2y1 y2 1 minus x square minus 2x times y1 square equal to 4y1. We can divide each term by 2y1. We will get this is y2. So y2 times 1 minus x square minus xy1 equal to 2. So this is part 1, because it was to prove that 1 minus x square y2 minus xy1 minus 2 equal to 0. So we have got this result. Now we have to apply Lebinitz theorem to find out nth derivative. So we write it on the next page. We have equation 1 minus x square y2 minus xy1 minus 2 equal to 0. So its nth derivative will be y n plus 2 1 minus x square intact plus nc1 y n plus 1, and then derivative of this minus 2x plus nc2 yn minus 2. Now derivative of this minus xy n plus 1 minus nc1 yn, and derivative of this will become 1. Now nth derivative of minus 2 will be 0, equal to 0. Now we simplify. So 1 minus x square y n plus 2 minus 2n plus 1 x times y n plus 1. Here nc1 equal to n, and minus n square yn equal to 0. Now we can divide each term by 1 minus x square. So this will become yn plus 2 minus, this will become 2n plus 1 yn plus 1 x divided by 1 minus x square equal to, if we write this to arches, n square yn divided by 1 minus x square. Now here we can put the limit. Let's write when x tends to 0. In that case, limit x tends to 0, we are going to do this portion. So limit x tends to 0, yn plus 2 divided by yn equal to n square. So limit x tends to 0, yn plus 2 divided by yn equal to limit x tends to 0. And here we are going to put x equal to 0. So here this term will become 0 and this term will become 0. So we will be left with yn plus 2 equal to n square yn. So we have to find out yn plus 2 divided by yn. So this will become only n square, or n square divided by 1 minus x square. And when we put value of x as 0, we get n square. So this portion is also put. Now we have to find out yn 0. So for this purpose, we have to take equation 1, and equation 1 was for first derivative, that was y1 equal to, we can refer in the back this equation, y1 equal to 2 sine inverse x divided by root of 1 minus x square. So let's write it here again. So 2 sine inverse x divided by root 1 minus x square, and we get y10, means we are putting x equal to 0, so this would be 0. Now we have to find out y20. So y20, so we have to refer the equation for y2. So if we put x equal to 0 in this equation, so here there is x, so this term will become 0 and this will become 0. So y2 minus 2 equal to 0, from where we get y20 equal to 2. Now we consider this equation. So yn plus 2 0. So here if we put x equal to 0, this term will become 0. So we will get n square yn equal to n square yn 0. Now we can put the values of n like n equal to 1, n equal to 2. Suppose we write n equal to 1. So this will become y30. So y30, we can take this on next page. So yn plus 2 0 equal to n square yn 0. Now we are going to put n equal to 1. So this will become y30 equal to n is 1, and this is y10. And y10 we have obtained here as 0. So answer will be 0. So this will be 0. So we have got y30. We have got y10 is 0. y20 we have got as 2. And y30 we have got as 0. Now let's put n equal to 2. So y40. So this will be 2 square times y20. And y20 is 2. So this will become 8. Or 2 square into 2. We can write 2 square into 2. So this is y40 is 2 square into 2. Now when we put n equal to 3, so this will become y50. So this will become 3 square, that is 9, into y30. Here, this will become y30. And y30 is 0. So this will become 0. So y50 is 0. So we are getting odd terms here, 0, y1, y3, y5, 0. So this is 0. Similarly, if we put n equal to 4, so y60. So here it will become 4 square and y40, because n equal to 4. So y40 is 2 square into 2. So this will become 2 square into 2. So we have got y60 equal to 4 square, 2 square into 2. So we can generalize it that for n equal to odd, yn0 is 0, and for n equal to even, yn0, we have got like 2, then 2 square, 2, then 4 square, 2 square, 2, etc. So we can write it like 2 into 2 square, 4 square. We are writing in reverse order. 2, 2 square, 4 square. The next will be 6 square. So this can be generalized as 2n, sorry, not 2n, n minus 2. N minus 2 whole square. Or we can write condition n is greater than 2. So this is answer. Now consider next question. We are given y equal to e to the power m cos inverse x. Then prove that 1 minus x square yn plus 2 minus 2n plus 1 yn plus 1 minus n square plus m square yn equal to 0, and also find yn 0. So y equals e to the power m cos inverse x. Now we find first derivative. So y1 equal to e to the power m cos inverse x times derivative of this. So minus m upon root of 1 minus x square. Now in place of e power m cos inverse x, we can write y. So minus my upon this. So this will become minus my divided by root of 1 minus x square, which is y1. So we can cross multiply. So y1 times root of 1 minus x square equal to minus my. We can square it. So if we square it, it will become y1 square 1 minus x square equals m square y square. We can differentiate it with respect to x. So this here product rule will apply. So this will become 2y1 y2 times 1 minus x square plus y1 square times minus 2x equal to m square into 2y y1. We can divide each term by 2y1. So we will get 1 minus x square times y2 minus from here x y1 equal to m square y. Now we can apply Lebinitz theorem to differentiate it n times. So let's proceed. So we have equation 1 minus x square y2 minus x y1 equal to m square y. Now using Lebinitz theorem, this will become y n plus 2 1 minus x square plus n c1 y n plus 1 and derivative of this. So this will become minus 2x plus n c2 y n, and this will become minus 2. Now derivative of this minus y n plus 1 x minus n c1 y n into 1 equal to m square y n. We can simplify. We can apply formula NCR equal to factorial n upon factorial r factorial n minus 1. So nc1 is n, nc2 is n minus 1 divided by factorial 2. So we can put this value and then we can simplify. So let's write y n plus 2 1 minus x square plus n times y n plus 1, and this is minus 2x plus this will become n into n minus 1 upon factorial 2 y n times minus 2 minus this will become, we can take minus sign outside for this. So this will become yn plus 1 times x minus this will become n times yn equals m square yn. Now what we do? We simplify it. We can take yn plus 1 and the yn plus 1 common from here and yn. So, and this 2 can be cancelled by it. Minus sign will be left. So 1 minus x square times yn plus 2 minus 2n plus 1 times xyn plus 1 minus n square plus m square times yn equal to 0. Now we have to get value of yn at x equal to 0. So we have equation y equal to e to the power m cos inverse x. So we can evaluate. First we get y0. So y0 will be e to the power m times cos inverse 0. That is pi by 2. Let's find out y10. So our equation for y1 was here. So we can take this. So if we put x equal to 0 here, so this will be y1 and here this will become y0. And y0 we have got as e to the power m pi by 2. So we write it. So our expression is here y1 0 we get. So that will be equal to minus m times e m pi by 2. Now y20. So y20 we have to find out. So expression for y2 is this. So it will become m square. Here x equal to 0, this term will vanish. Here this term will also vanish. So we will have m square times y. Here we are putting 2. Sorry, x equal to 0, and so this will become m square y. This term will become y0. And y0 we have got as e to the power m pi by 2. So this term will become m square e to the power m pi by 2. Now, from this equation, we can get yn plus 2 0. So let's write it on next page. Our equation was 1 minus x square yn plus 2 minus 2n plus 1 times yn plus 1 times x minus n square plus m square times yn equal to 0. Now we are going to get yn plus 2 0. Means we are going to put x equal to 0. So this term will become 0 and we will get this yn 0. So yn plus 2 0 is equal to n square plus m square. Here this term is shifted to RHS times yn 0. Now we can put n equal to 1. So when we put n equal to 1, so we get y30. So let's write it y30 equal to. We are putting n equal to 1, so this will become 1 square plus m square. And n equal to y10. And y10 equal to y10 we have got as minus m e to the power m pi by 2. Now we put n equal to 2. When we put n equal to 2, this will become y40. So this will become 2 square plus m square, and this will become y20. And we put the value of y20, and y20 was y20 we have obtained as m square e to the power m pi by 2. So we put this value here. 2 square plus m square times m square into e to the power m pi by 2. Now, suppose we put n equal to 3. If we put n equal to 3, so this will become y50. So here n equal to 3, so this is 3 square plus m square into this will become y30, and the y30 we have obtained as this. So this value we can put here. So this will become minus m times 1 square plus m square times 3 square plus m square into e to the power m pi by 2. Now, similarly, we can put n equal to 4. So let's put it. When we put n equal to 4 in this equation, so n equal to 4 means y60. This will be 4 square plus m square plus y40. And the y40 is this much. So this value we will put. So let's write it. N equal to 4, then y60. So y60 is equal to 4 square plus m square times y40. And we have value of y40. So we can put it here. So we will get m square times 2 square plus m square. This is value of y40 into e to the power m pi by 2 times this value 4 square plus m square. Now, we can generalize it yn0. So it will become minus minus m e to the power m pi by 2 times 1 square plus m square, then 3 square plus m square, then dot n minus 2 square plus m square. This is yn0 when n equal to odd. And for even yn0, we will take this 2 square, 4 square. So when yn0 for even, so this will become m square e to the power m pi by 2, then 2 square plus m square dot 4 square plus m square dot n minus 2 whole square plus m square. So this is it. Thank you for watching.